grounding electrode conductor appears to be a solid copper conductor. Determining the exact size from the picture is difficult. However, it's likely sized according to the National Electrical Code or NEC requirements for the specific grounding system in use. The NEC dictates the minimum size of the grounding electrode conductor based on the size of the ungrounded service conductors. This ensures a low impedance path for fault current back to the source. The grounding electrode conductor connects the service equipment to the grounding electrode, which could be a ground rod, a ground ring, a metal underground water pipe, or other approved grounding electrodes. Proper sizing is crucial for safety and effective fault current clearing. A conductor that is too small may not be able to safely carry the fault current, potentially leading to equipment damage or even fire. The bonding conductor appears to be a bare copper conductor. Again, determining the precise size from the image is challenging. It is most likely sized according to NEC requirements for the specific bonding application. Bonding conductors are used to connect metallic parts of electrical equipment and systems to create a low impedance path for fault current. This includes bonding metal enclosures, raceways, and other non-current carrying metal parts. The purpose of bonding is to minimize voltage differences between these parts, reducing the risk of electric shock. The NEC specifies the minimum size of bonding conductors based on the size of the circuit conductors. This ensures that the bonding conductors can safely carry the fault current. Similar to grounding electrode conductors, undersized bonding conductors can pose a safety hazard. Overall, the grounding electrode conductor and bonding conductors appear to be installed correctly and in accordance with the NEC. However, a complete evaluation of the size and condition of the conductors necessitates additional information or an on-site inspection. An on-site inspection would involve physically examining the conductors, measuring their size, and verifying their connections. It's important to ensure that the conductors are free from damage, corrosion, or other defects. It is also important to verify that the connections are tight and secure. In addition to visual inspection, electrical testing may be necessary to verify the integrity of the grounding and bonding system. This can include measuring the resistance of the grounding electrode system and performing impedance tests on the bonding conductors. These tests can help identify any potential problems with the grounding and bonding system. Ensuring the grounding and bonding system adheres to NEC requirements is crucial for electrical safety. It helps protect people and equipment from electrical shock and fire hazards. Regular inspections and maintenance of the grounding and bonding system are essential to ensure its continued effectiveness. If any issues are identified during an inspection, they should be addressed promptly by a qualified electrician. The NEC provides detailed requirements for grounding and bonding in Article 250. This article covers a wide range of topics, including the selection and installation of grounding electrodes, grounding electrode conductors, and bonding conductors. It is essential for electricians and electrical contractors to be familiar with the requirements of Article 250 to ensure that electrical systems are installed safely and in accordance with the code. Some key aspects of grounding and bonding include the following. Firstly, the purpose of grounding is to provide a low impedance path for fault current back to the source. This helps to quickly trip the overcurrent protection device, such as a circuit breaker or fuse, to energize the circuit and prevent electrical shock or fire. Secondly, bonding is the process of connecting metallic parts of electrical equipment and systems to create a low impedance path for fault current. This minimizes voltage differences between these parts, reducing the risk of electric shock. Thirdly, the grounding electrode conductor connects the service equipment to the grounding electrode. The size of the grounding electrode conductor is determined by the size of the ungrounded service conductors. Fourthly, bonding conductors are used to connect metallic enclosures, raceways, and other non-current carrying metal parts. The size of the bonding conductors is determined by the size of the circuit conductors. Fifthly, grounding electrodes can include ground rods, ground rings, metal underground water pipes, and other approved electrodes. The selection of the appropriate grounding electrode depends on the soil conditions and other factors. Sixthly, all grounding and bonding connections must be tight and secure to ensure a low impedance path for fault current. Seventhly, regular inspections and maintenance of the grounding and bonding system are essential to ensure its continued effectiveness. When evaluating a grounding and bonding system, it's important to consider several factors. These include the size of the conductors, the type of grounding electrode, the tightness of the connections, and the overall condition of the system. It is also important to verify that the system complies with the requirements of the NEC. If any issues are identified, they should be addressed promptly by a qualified electrician. For example, if a grounding electrode conductor is found to be undersized, it should be replaced with a conductor of the correct size. If a bonding connection is found to be loose or corroded, it should be cleaned and tightened or replaced. If the grounding electrode is found to be damaged or ineffective, it should be replaced with a new grounding electrode. The NEC also addresses the use of different types of conductors for grounding and bonding. Copper conductors are the most common type of conductor used for grounding and bonding. Copper is a good conductor of electricity and is resistant to corrosion. Aluminum conductors are also permitted for grounding and bonding, but they must be properly terminated and protected from corrosion. The NEC specifies the types of connectors that are permitted for use with aluminum conductors. In addition to copper and aluminum, other types of conductors may be permitted for grounding and bonding in certain applications. However, it is important to verify that the conductors are approved for the specific application and that they are installed in accordance with the NEC. Grounding and bonding are essential components of a safe and effective electrical system. Proper grounding and bonding help to protect people and equipment from electrical shock and fire hazards. It is important to ensure that grounding and bonding systems are installed correctly and maintained regularly. The NEC provides detailed requirements for grounding and bonding, and it is essential for electricians and electrical contractors to be familiar with these requirements. By following the NEC requirements, it is possible to create a safe and reliable electrical system. When examining grounding electrode conductors, look for proper connections to the grounding electrode and the service equipment. The connection should be made with approved connectors and should be tight and secure. The conductor should be protected from physical damage and corrosion. When evaluating bonding conductors, check for proper connections to the metallic parts of electrical equipment and systems. The connection should be made with approved connectors and should be tight and secure. The conductor should be protected from physical damage and corrosion. Also, ensure the path to ground is continuous and has low impedance. Verify that all metallic parts are effectively bonded together. Check that the grounding electrode is appropriate for the soil conditions. Measure ground resistance to confirm it is within acceptable limits. Look for signs of corrosion or damage on conductors and connections. Confirm that the size of the grounding electrode conductor and bonding conductors are appropriate for the system.